Hey students, this is lesson 8.1. This is a review of Pythagorean's theorem. You will learn how to use Pythagorean's theorem and its converse. So here's just to get rid of here, I'll do a couple of these problems just so we remember how to do these. These are actually proportional if we think of these ratios as over 1. So number 4, that would be the one maybe that you would have the most trouble with. We have x times 1 should equal 0.5 times quantity 3x plus 5. And we can go ahead and use a distributive property, or we could divide both sides by 0.5. 1 divided by 0.5 is 2x, so I think I'll do that way. Divide both sides by 0.5. And so 2x is equal to 3x plus 5. Subtract 3x from both sides and we get negative 1x equals 5. And then divide both sides by negative 1 and we get x equals negative 5. So, and just one more thing here, with a problem like this where we're dividing 24 by x, that would create this equation 0.5858 times x equals 24. So we need to divide 24 by 0.5858. All right, proving triangle similar. The things that we learn to use the postulates of theorem are the angle-angle similarity postulate, the side-angle-side similarity theorem, and the side-side-side. All right, so if we look at, maybe I'll do this number 7 here with you, and you can do the other two, but we can see that JK is perpendicular to ML, so that gives us this, 2 right angles there. And then if we use corresponding sides, JK, that length is 20. So if we compare that to the same leg on the smaller triangle, that would be 15, so 20 over 15. If that is equal to the ratio of the longer leg from the smaller triangle to the longer leg on the on the bigger triangle, which is 28 over 21. If that's true, then these are then we can use side angle side similarity. So 20 over 15 is the same as 4/3. 28 over 21 is the same as 4/3. So we have equal ratios here. So we're going to say by side, those aren't equal, but they're similar. And we saw that that other leg has an equal ratio. So we're going to use side angle side similarity there. And then down here, this is kind of a review of those means theorems, the triangle altitude theorems. So I guess we could pick, maybe we'll do number 10 here. So if we want to find CD, this length right here, we know that, let's call it, we just need to find x here. So this is actually the geometric mean of this length 4 and then the total length, which is 13. So we could say 4 over x is equal to x over 13. And then solve that. X squared equals 13 times 4 is 52. So x equals the square root of 52, which we can simplify that. That's the same as square root of 4 times square root of 13, or 2 times square root of 13. All right? Okay, so this lesson reviews Pythagorean's theorem and its converse. Pythagorean theorem says that in a triangle, the triangle is the right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. In symbolic terms, that's a squared plus b squared equals c squared. So if we have side lengths 5 12, and 13, the hypotenuse is always the longest side, so that would be your hypotenuse, and these two would be legs. So we need something like this relationship here for it to be a right triangle. All right, underline the correct words to complete each sentence. A triangle with side lengths 3, 4, and 5 is a right triangle because 3 squared plus 4 squared is equal to 5 squared. Triangle with side lengths 4, 5, and 6 is not a right triangle because 4 squared, which is 16, plus 5 squared, that's 41, is not equal to 6 squared, which is 36. So those are the ideas we're going to use. So what is the length of the hypotenuse of triangle LMN? Do the side lengths of LMN form a Pythagorean triple. A Pythagorean triple is when you have a squared plus b squared equals c squared, and a, b, and c are all whole numbers. So if we do this, we're going to do 8 squared plus 15 squared is equal to c squared, and that's 64 plus 225, and that's equal to 289. And now we just want the positive square root of 289, and that's 17. And since c is also a whole number, this is a Pythagorean triple. So we're going to say yes. All right? I think I'm going to skip over this. I think you can handle these Pythagorean theorem problems. Okay, what is the value of x? Express your answer in simplest radical form. Well, Pythagorean theorem says that the area of the squares on the legs added together equals the area of the square on the hypotenuse. So that means 10 squared plus x squared is equal to 16 squared. And so then we get 100 plus x squared equals 256. Subtract 100 from both sides. We get x squared is equal to 156. And then we want the positive square root of 156. And we want the answer in simplest radical form, so we have to think of a number that goes into 156 and is a perfect square. So I'm thinking maybe for sure 4 goes in there. Let's try that. And 4 goes in there 39 times. And 39, the only factors of 39 are 3 and 13, so that's doesn't have any perfect square factors. So 2 times the square root of 39 is in simplest radical form. All right? Problem 3, finding distance. Jamal leans a 12-foot long ladder against the side of a house. The base of the ladder is 4 feet from the house to the nearest tenth of a foot. How high on the house does the ladder reach? So we have a house here, and we have a ladder leaning up against the house. And we have to assume here that the ground is flat for this to work, but if we lean the ladder, and the ladder is 12 feet long, that would look like that, and this is 4 feet there, and we want to know how high it reached. We'll call that h. So we get 4 squared plus h squared is equal to 12 squared. And then, simplifying that, we get 144, and then we get h squared is equal to 128. So h is the positive square root of 128. And it says we just want that to the nearest tenth of a foot. So I'm just going to grab a calculator and do the square root of 128. And that equals 11.313. So for the nearest tenth of a foot, h is approximately 11.3 feet. All right. You can go ahead and try this problem, and I'll give you the answers. All right, a triangle and side lengths 12 and a half, 30 and 32 and a half. Is it a right triangle? Explain. If it is a right triangle, then we should be able to take the two shorter sides and square those and add them together, and they should equal the longest side squared. So what we're checking is this is 12 and a half squared plus 30 squared equals to 32.5 squared. So we're going to do 12 and a half squared and 30 squared. 30 squared is 900. 12 and a half squared is 156.25. And 156.25 plus 900 equals 1056.25. And we're going to do 32 and a half squared. And that equals 1056.25. So, since we get a true statement, this triangle has to be a right triangle, according to the converse of Pythagorean's theorem. We'll just say by converse of Pythagorean's theorem. All right. Okay, another theorem here that we're going to use is the Pythagorean inequality theorem. If the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, then the triangle is obtuse. So if c squared is greater than a squared plus b squared, then it's an obtuse triangle. And if the square of the length of the longest side of a triangle is less than the sum of the squares of the other two sides, then the triangle is acute. So if s squared here, which is the longest side, is less than r squared plus t squared, the triangle is an acute triangle. So let's use that idea here. Let's take the two shorter sides and square them. And that gives us 16 plus 81, which is 97. And then we're going to do 12 squared, which is 144. Since 97 is less than 144, so our c squared is greater than our a squared plus b squared, we're going to say that this will create an obtuse triangle. All right. Lesson check. Triangle has side length 16, 34, and 30. Your friend says it's not a right triangle. Look at your friend's work and describe the error. All right. Underline the length your friend used as the longest side. That one. Our friend should have done 16 squared plus 30 squared is equal to 34 squared. So our friend used the wrong number for the hypotenuse. All right, that's it. See you tomorrow.